Welcome. Today, we're diving into something truly fascinating. We are going on a deep dive into the literal, invisible biology running your life right this very second. You see, health isn't just some random collection of good habits you try to maintain. It is the emergent result of countless, deeply interconnected biological processes happening every single moment. So in this explainer, we're going to pull back the curtain on the hidden mechanisms that actually dictate your performance, your aging, and your cognition.
So, I want you to think about this question. What invisible biological forces are shaping the quality of your life every single day? We usually think of our energy levels, our mood, our ability to focus as things we can just willpower our way through, right? But beneath your conscious awareness, there is a hidden operating system, and it's dictating exactly when you thrive and exactly when you crash.
Think about this for a second. 1/3 of your entire life is governed by a singular invisible molecule, a master regulator of your sleep and your energy. We're about to uncover this mystery molecule, and we'll see how it acts as the absolute dictator of your daily rhythm, how it controls your brain networks, influences your hormones, and ultimately shapes your biological destiny. And that molecule is adenosine. Now, formally, it's an endogenous nucleoside, but practically speaking, it's your brain's absolute master regulator. It doesn't just make you feel sleepy. It literally connects your cellular energy metabolism directly to your sleep-wake control. It protects your heart, it regulates blood flow, and it acts as this microscopic biochemical ledger, tracking exactly how much energy you've burned today.
Section 1. The Invisible Energy Thief.
To really get how to optimize your health, we've got to zoom way in, down to the microscopic level. We need to look at the hidden cost your body pays for every single second you stay awake. Every time you think or move or even just breathe, your cells are burning energy. Specifically, a molecule called ATP. But when ATP is burned, it leaves behind a byproduct, adenosine. Think of it as cellular exhaust. The longer you're awake, the more this exhaust piles up in your basal forebrain. It accumulates like sand in an hourglass, creating this heavy, inescapable weight that scientists call homeostatic sleep pressure.
So here's how this cycle plays out every day. You wake up, adenosine is low. By the afternoon, that accumulation peaks, dragging your energy down. And by nighttime, the pressure is immense. But when you finally fall asleep, these incredible star-shaped cells in your brain called astrocytes go to work. Using an enzyme called ADK, they literally sweep through and clear out this exhaust, resetting the hourglass for tomorrow. But keep those astrocytes in mind, because later on, I'm going to share a pretty wild secret about them.
Section 2. The Great Caffeine Illusion.
Okay, so what happens when we try to cheat this biological clock? Well, we're about to shatter a massive myth that most of the world relies on every single morning. The biological truth here is staggering. Caffeine provides absolutely zero actual energy. None. Zero. Instead, its molecular structure is just incredibly similar to adenosine. So it acts as a chemical imposter. It sneaks into your brain, plugs up those adenosine receptors, and essentially blindfolds your brain so it temporarily can't feel the fatigue that is absolutely still there.
Let's actually walk through how that infamous afternoon caffeine crash happens. Step 1. Caffeine blocks the receptors. You feel alert. Great. But step 2. Your cells are still burning ATP, which means that adenosine exhaust is still building up in the background. Step 3. The caffeine eventually unbinds and wears off. And then step 4. The dam breaks. All that built-up adenosine rushes in and violently binds to your receptors all at once. That's the crash. You didn't run out of energy, you were just hit by a delayed avalanche of cellular exhaust.
But here's the catch. Your brain is incredibly smart, and it fights back against this chronic caffeine blockade through a process called upregulation. Because you keep blocking the signal, your brain kind of panics and builds more adenosine receptors to try and catch all that exhaust. That creates your tolerance. You now need more caffeine just to feel normal, and when the crash hits these newly minted receptors, it is far more intense. You are basically trapped in a biological debt cycle.
Section 3. Opening the sleep gates.
So how does the brain actually manage this exhaust when we don't interfere? Let's look at the evolutionary origins. Adenosine doesn't just do one thing. It operates through two distinct gates. First, you've got A1 receptors. Think of these as the brakes. When adenosine binds here, it literally suppresses the arousal setters in your brain. Then, you have the A2A receptors. These are the switches. Adenosine binds here to actively excite sleep-promoting neurons deep in your hypothalamus. Brakes on wakefulness, switch on sleep. But science is always peeling back deeper layers, right? Remember those star-shaped astrocyte cells we talked about earlier? Well, researchers recently made a stunning discovery.
Yes, they clear adenosine, but astrocytes can actually regulate your sleep-wake behavior through internal calcium activity that is completely independent of adenosine signaling. Driven by your local neural activity, these cells act as parallel regulators, fine-tuning your brain's need for sleep based on how hard you've been thinking. It is an absolute masterpiece of interconnected biology.
Section 4. The stress-sleep connection.
Now we really have to ask the tough question. What happens when this entire system breaks down? When we chronically cut our sleep short, we aren't just feeling a little tired. We're triggering a massive, dangerous biological cascade. The brain undergoes something called maladaptive receptor remodeling. In your hippocampus, which is the memory and stress center of your brain, chronic sleep loss physically decreases the density of your A1 brake receptors and unnaturally increases the A2A switch receptors. Your brain is literally changing its physical structure in a dangerous way.
And this structural remodeling sets off a terrifying chain reaction. Step 1. Those A2A receptors upregulate. Step 2. This directly throws your HPA axis, your body's central stress response system, totally out of whack. Step 3. This triggers massive spikes in the stress hormone, cortisterone. Step 4. This biological storm actually manifests as depression-like behaviors and emotional fragility. So a lack of deep sleep isn't just an inconvenience, it paves a direct physiological pathway right to systemic inflammation and mood disorders.
And it goes way beyond just your mood. If you persistently deny your body sleep, that prolonged A1 receptor activation in the hippocampus literally suppresses something called LLTP, late-phase long-term potentiation. In plain English, it stops your brain's synapses from rewiring. It actively blocks your brain from consolidating spatial and declarative memories during sleep. By forcing those sleep gates shut, you are quite literally erasing your own ability to learn and remember.
Section 5. Your hidden operating system.
But hey, knowledge is power, right? Once you understand the machine, you can optimize it. It's time to shift from the damage of modern habits to real biological empowerment. If you're caught in that biological debt cycle of caffeine and adenosine upregulation, there is a way out. Science points to a very specific number, 7 to 14. That is the number of days of going caffeine-free required to naturally downregulate those adenosine receptors. In just 1 to 2 weeks, you can allow your brain to physically heal, stripping away those excess receptors and completely normalizing your baseline sensitivity to your own natural energy.
So let's tie all of this together. Health is never just a list of random isolated habits. It's an interconnected cascade. High sleep quality ensures optimal adenosine clearance. Proper clearance maintains your HPA axis stability. A stable nervous system allows for true stress recovery. And deep recovery is the ultimate foundation for cognitive longevity. Every single choice you make echoes through this entire chain. We started this explainer by asking what invisible forces are running your life. Well, now you know. It's this elegant, relentless molecular dance of energy and exhaust, of brakes and switches, of stress and recovery. So I want to leave you with this final, provocative thought. Now that you actually know the invisible biological forces running your body, how will you program tomorrow's operating system today? Thank you for exploring this with me.